right, using the fundamental identities, today is the 26th. February's almost done. It's really exciting. All right, so multiplying by the conjugate. Multiplying by the conjugate is a fantastic skill. Here we really want to know what it means to what a conjugate is in math. To conjugate is to like conjugate a verb in any other language. In English, all our verbs are irregular. It's very weird. So, but in Spanish, you can conjugate verbs all over the place. Here, to conjugate means to change the sign, one sign. So to multiply by the conjugate would be to multiply by radical 5 plus 4. We're going to multiply. Now, if we multiply the denominator, we also have to multiply that to the numerator. And this is allowed because I'm only multiplying by what is effectively 1. And then it cleans up super nice. When we multiply by the conjugate, we create this sum and difference pattern, which is always going to clean up. Super awesome. So in my numerator, I get 3 times radical 5 plus 4. I could distribute if I wanted to, but I don't. No, if I need to. Let's see what happens on the bottom. First times first. What's radical 5 times radical 5? 5. The outside is 4 radical 5. The inside is negative 4 radical 5. What do those do? They cancel out to be 0. And then last times last is negative 16. And so we get 3 times the quantity radical 5 plus 4 over negative 11, which is a fine answer. It's not very pretty, but it works. So multiplying by the conjugate. This is a skill that we use a lot in calculus to clean things up, make them easier to differentiate. So we're doing a little bit of that today. So example 1, multiply by the conjugate to establish the identity. Multiply by the conjugate to establish the identity. So again, these two things are equal, and our job is to show how to transform one side into the other. I typically always start with the side that's a fraction. It seems a little more difficult than the side that doesn't have a fraction. All right, so we have 7 over cotangent of x plus cosecant of x. And we're going to multiply by the conjugate of the denominator. So what is the conjugate of this expression? Cotangent of x minus cosecant x. I'm just smushing it in there. Cotangent of x minus cosecant of x. I'm going to multiply on top and bottom. Again, we're multiplying by the same thing on top and bottom. It's like multiplying by 2 over 2 or 12 over 12. It's the same as multiplying by 1. So you'll notice my numerator looks fairly close to what we have there. I'm going to leave it 7 times cotangent of x minus cosecant of x. And then let's see what happens when we multiply on the denominator. Cotangent times cotangent is cotangent squared of x. What happens with the outside and the inside? They cancel out. Yeah, negative cosecant cotangent and positive cosecant cotangent. Negative and positive 0. And then last times last would be negative cosecant squared of x. And then I'm thinking, hey, I've got things that are being squared. So I'm thinking possibly, is this a Pythagorean identity? So I need to go to my memory bank here. What's the Pythagorean identity with cotangent? Cot plus 1 equals okay, cosecant theta. So cotangent squared theta plus 1 equals cosecant theta. Okay, let's rearrange this identity. So it looks like this one. I have cotangent squared. I need to subtract cosecant squared. So I need to move this over here. So I get cotangent squared minus cosecant squared theta. So what do we have to do with the 1? Subtract it to the other side. So that's going to equal -1. So I can replace this with a -1. 7 times the quantity cotangent of x minus cosecant of x, all divided by, what do I replace this with? -1. It's the same as a -1. So what's the difference between what I have and what is over here? It's not negative, is it? Okay. So what else changed? These are flipped, aren't they? Okay. They're opposite. This -1 can either, we could put it on the -7 if we wanted to. In fact, let me just do that. It's the same to say this is -7 times cotangent of x minus cosecant of x. What happens if I just take my negative and I distribute it? Yeah, so if I leave the 7 and I just distribute the negative, that gives me negative cotangent of x plus cosecant of x. Now, is that what we have here? Yes, it is. All right, and so those are identical. We could leave it like that if we wanted to. Cosecant of x minus cotangent of x. All right, so that's one way you could do that. The hard part about identities is that there really are an infinite number of methods to simplify these things. And that's what is powerful about algebra. Once you learn the techniques, you can do them in all sorts of different orders and all sorts of different ways and still end up with the same result, as long as what you're doing is true, which is really, really cool. So that's one thing that you're going to do a little bit of today. Multiplying by the conjugate. Any questions on that one? Not too bad. All right, here's some interesting stuff. This is more sort of, hey, here's what you're going to see in calculus. Example 2, use the trig substitution to write the algebraic expression as a trig function of theta. That should be just function of theta, where theta is between 0 and pi over 2. We don't really care about that. We have the square root of 4 plus x squared is equal to, or sorry, not is equal to. And we also have x is the same as 2 tangent of theta. All right. So we have two things going on. We have this thing here, which would be called an algebraic expression. It's got numbers and letters and symbols and X's. Okay, algebraic expression. An expression does not have an equal sign. It's just like one side. And so there's our algebraic expression. And we want to take this same algebraic expression and write it as a trig function in terms of theta. And so they've given us basically a substitution. So they're telling us x is the same as 2 tangent of theta. So I'm just going to go ahead and substitute that. I missed. I'm going to drop it in place of the x. So that gives me 4 plus, now I'm substituting in place of x, so 2 tangent of theta, and it's going to be squared. So be careful when you substitute. You want to really do this the right way. And so let's see, 4 plus, what is 2 tangent theta quantity squared? Two tangent theta times 2 tangent theta would be 4 tangent squared of theta. Tangent times tangent would give me tangent squared. Okay. And then to simplify this, this is the only time you can simplify under a radical. This has a greatest common factor of what? 4. Okay. So I'm going to take out the 4. And what's left behind would be what? 1 plus tangent squared of theta. Ooh, something squared with 1s. What is that? 1 adds a tan. By the C, by the C. So now we have 4. And then in place of 1 plus tangent squared, we get secant squared of theta. Now you'll notice it's no longer addition anymore, is it? We've simplified this down to now it is a product, and now we can take the square root of it. What is the square root of 4? 2. And what's the square root of secant squared? Secant. Okay? This is the only time we can actually simplify something under a radical that looks pretty complicated. So it's kind of nice. You'll do this quite a few times. I think it's a miracle how it cleans up. It's really cool. All right, any questions on that? It's pretty good. Got some nice sort of formulaic stuff today. All right, one more. Step 3, verify the identity, LCD. LCD, what does LCD stand for? Lowest common denominator. It's just a suggestion, by the way. Multiplying through by the LCD, lowest common denominator, is a method that works sometimes. The hardest part about identities is knowing what method to use. And I'll go through and do the homework and be like, oh, that was clearly the wrong way to do that. Cross it out, try a different method. Sometimes it's unclear. This one, it's very ironic that I actually tried this last night and couldn't do it. But then when I walked in this morning and looked at it, I was like, oh, that was actually easier than I thought it was. Okay. Obviously, we have a difficult side and a more simple side over here. So I'm going to try and clean up this complicated looking side. And to do that, I'm going to look and trade that secant in for 1 over cosine of x. What I've created here is a complex fraction. And when I look, this all has a denominator of 1, but this one has a denominator of cosine of x. So the LCD in this case, I can multiply by cosine of x on top and bottom, because again, that's allowed since it's the same as multiplying by 1. And then I'm going to go ahead and distribute in my numerator and see what happens. What is cosine of x times 1 over cosine of x? 1. And then cosine times negative 1? Negative cosine. In my denominator, I'm going to go ahead and leave it factored. Now what happens? It cancels out. Yeah, 1 minus cosine of x on top and 1 minus cosine of x on bottom. Goes into itself one time. Hey, that was pretty easy. 1 over cosine of x is left over. And what is 1 over cosine of x? Secant of x equals secant of x. And that was really nice and simple. I don't know what I was doing. I tried multiplying by the conjugate last night when I was working on this. And that just was a big giant mess. And it happens. You go through and you'll do stuff and it just turns into a bigger and bigger mess. It's like a Pandora's box of mess. And stop and try again. Okay, don't erase, just cross it out and start over. Do you guys have any questions for me? All right, today's kind of a nice day. CP32, I'll pass it out.